Mm-hmm.
Okay. So once you have your part, looks like it's an imported part that you saved it in Alibre. So once you have the part loaded, you just go up to the add-ons tab in the ribbon bar in Alibre Design, and then
Yes.
you would locate the AlibreCAM pull-down menu, and then you select Mill. So
Okay.
this automatically loads the AlibreCAM interface. It tells us that the units is not supported in here because the part that you have is not in inches or millimeters. So the first step is we need to go to the properties in here and set the model units to inches or millimeters. Do you have a preference?
It's inches is what it's
Inches.
drawn in.
Okay.
Yeah.
All right. So I'm going to set the units in here, and all I got to do is go back and launch the CAM interface. So the AlibreCAM interface shows up. You can see that the AlibreCAM's browser windows appear as a tab right next to your Design Explorer. So you can switch between Alibre Design and AlibreCAM by just a single click of a button. Do you have any questions, Michael? Okay.
All right.
So I just switched the units in Alibre Design to inches, and the AlibreCAM plugin loads up if you're working in inches or millimeters, and you'll see that the AlibreCAM's interface appears right next to your Design Explorer, so you can switch back and forth between your Design Explorer and AlibreCAM by just toggling the tab down at the bottom of your Design Explorer window. You can also resize this in here, so to see all of the contents in the AlibreCAM machining interface. So you have the machining browser on the top half, and then the machining objects browser over here in the lower half of the screen. So the machining operations browser has two main tabs. You have the program and the simulate tab. So the program tab has three major groups in the ribbon interface. You have the machine setup, you have the stock, and then the machining operations. Now the mill module of AlibreCAM comes in 5 different levels or configurations. We have Express, Standard, Expert, Professional, and now we also have Premium configuration for full 5-axis machining. Now, as you're going to be doing mostly 2.5 and 3-axis machining, you could consider the standard configuration, which gives you a wide range of methods in 2-axis or 2.5-axis, starting from roughing, facing, pocketing, profiling, V-carving, engraving, slot machining, chamfer, filleting, hole pocketing, hole profiling, thread milling, and T-slot machining. The Pro also includes remachining. Now, in the 3-axis methods, you will have access to roughing, parallel finishing, horizontal finishing, radial, and spiral machining as part of the standard configuration. The Pro configuration includes the advanced 3D machining methods. The 4-axis is available starting with the Expert configuration. The 5-axis simultaneous is available in the Premium configuration. The indexed 5-axis or positional 5-axis is available in the Pro, starting with the Pro configuration. The whole machining is available in all configurations. Drill, tap bore, and reverse bore available right from standard configuration of the product. So the typical workflow in here is once you have the part imported and you're ready to program it, you go down to the Program tab and you click on Machine. And this step allows you to define the machine tool coordinate system, so which allows you to establish your X, Y, Z axis orientation. So we use the same representation as Alibre does. The red arrow represents your Z axis. The green arrow represents your X, and the blue arrow represents the Y coordinate axis. And by default, the coordinate system for machining is in the same orientation as the world coordinate system that you have in Alibre, and it's at the origin where you have in Alibre. Okay?
Yes.
Now, this particular part, would you like to program from the back side first, or would you like to program?
I would do the top side, and what I had interest if we could program it. Like it'd be boring the holes, and then it's got that shoulder there. So mill.
Okay.
Like if the material was full thickness of the highest point there, mill the shoulder back.
Okay, sure, we can certainly do that. Now, so what I'm going to do here is leave it in the same orientation right now, and then in the next step, you specify the machining process for 2 and 3 axis. You leave it as 3 axis. We also have 4 and 5 axis options available in here. You can see that the machine is now defined as 3 axis. The next step, you can select your post processor. This would be the machine tool that you're going to be outputting the code for. Now, AlibreCAM has posts for over like 300 plus different post process listed in here, so it covers a wide range of machine tools. that are out there. So you can see the post processor, either they're listed by the name of the machine or by the name of the controller. So if you're looking for the Achromatic in here, there's an Achromatic 2100E. If you're looking for the one from Southwestern Industries, it's called the ProtoTrack. We should be able to find the ProtoTrack post in the list in here as well. So you have the ProtoTrack AGE3, just a standard ProtoTrack post processor in here.
Right.
So we pick one of the posts in here. You then set the extension for the file, NC, CNC, or whatever is the preferred extension. You can specify it, or if you need to add it, you can say add new to add a new extension. So your post is set up right here. The next step is you want to create your workpiece, the stock material. Right from the standard configuration, you can define box and cylinder stock. So for this particular part, since the part is round, I would go with a cylinder stock, unless you want to start with a rectangular piece of block and then cut around it.
Right.
So would you be starting with a round blank, like a cylinder blank?
Yes. Yeah, round blank.
Okay, so we'll pick cylinder, and then we'll pick the axis as Z, and then if you pick copy model bounding cylinder, you'll notice that it automatically computes the radius and the length.
Right.
And you can set the radius, if that's going to be 7.5, which is 15 inches in diameter. You can establish the radius, and you can also set the length, which is basically the height or the thickness of the blank. Now, would you be starting with the stock that has slightly more thickness to it?
Yes.
Okay. You want to go like 100 thousandths, or what would you like to add to it, sir?
That'd be fine.
Okay. So I'm going to put in 4.1. So the stock is now defined right in here. And then the next step, you can see that the stock preview is dried up on the screen. And if you wanted to align the stock, we want to align it. So we want to make sure that the bottom of the stock is flushed with the bottom of the part, right? So we can face off the 100 thousandths on the top of the workpiece. So I'm going to set it to Z alignment to the bottom and the XY to the center. Accept it.
Okay.
So we establish the XY origin. Now, the next thing we're going to do here is basically set the location of XYZ0, which is basically by doing a work 0. We can choose where you want to establish your XYZ origin, and you can specify it to set to the stock material. You could do highest Z, which is the top face, and you can put it in the center. Or you can put it to the highest Z top face of the part or top face of the stock. So you notice that the stock is 100 thousandths, has more thickness above the part. So you can pick where you want to put the 0 location in here, whether you want to do stock or part. Would you let me know where you want to put the origin to?
Probably the stock.
Stock, okay. So highest Z, center, or since it's a round blank, we would want to put it in the center. If it's a rectangular blank, you can pick even one of the corners. And you can also output your work coordinate offset, whether it's a 54 or 55. If you want to call out the work offset number, you can specify it right in here.
Okay.
So you'll notice that now the world coordinate system, which is the origin in the CAD, is still at the bottom of the part, the way you have it designed in Alibre. But the origin for machining, which is the work 0, is now translated to the top. So all your coordinates, all your toolpath motions will be computed based off this origin.
Right.
Okay. The next step is we can pick the material, what type of material you would like to use for milling this part. We have a list of materials that are included.
Steel.
Steel, okay. Do you happen to know if it's the 303 or 304 or what type of steel you're going to be cutting?
No, it's 836, but it probably just, if you did the 1010, that would probably do the job.
Okay, I'll just select that. And then you can see it also applies a texture in here. So as you go to the Simulate tab, if you click on Simulation window, it actually displays the stock material that you created in the simulation window. You can also apply a texture, so it applies the texture that you selected for the material. And the list of materials can be customized, so you can add additional material types to it as well. Okay, so now let's go back and program this part. So as you notice, the workflow is going from left to right as you work through each of these groups in here. So we established 0. The next step is to select tools. I already have some tools loaded from my library in here, so you can customize your tools. You can bring in your library, or you can use the default library that comes included with AlibreCAM, and you can customize it, edit it as well. So you can specify the type of tool that you'd like to use. We have different tool types, starting with ball mill, flat mill, corner radius tools for engraving, chamfering, taper, thread mill, face mill. You have your dovetail cutters. Fillet mills can be used for like corner rounding, lollipop cutters, and also you can do form tools. You have your drill, center drill, reamer, tap, bore, and reverse bore. You can define tools under each of these tool types. You can also specify the material for the tool that you're going to be using, whether it's carbide or high-speed steel. You can set the feeds and speeds in here for each of the tool. We also have a built-in feeds and speeds calculator in here. So depending on the stock material you're cutting, the tool material, the surface speed is a property of the material you're cutting, and the feed per tool is the property of the cutting tool. You can see that it automatically recommends speeds, and you can also customize this as you need to. So I can click OK to accept it. If I change the tool material to carbide, you'll see it automatically changes the cutting feed rate and the properties in here.
Right, yeah.
And you can also set the maximum feed rate, spindle RPM your machine can handle. So it could be, for example, 25,000 RPM, and the maximum cutting feed rate your machine can go, like 150, for example.
Right.
So I put that in there. It'll ensure that the feed rates are not going past or computed are not over 150, and then the spindle RPM is restricted to 25,000.
Yep.
So if I change the material to high-speed steel, you'll notice that it automatically changes. I can accept those values and then save it as the tool. Will automatically update the tool. So the first step is we wanted to face it down to the thickness of the part, the height of the part, and then we want to go ahead and remove the material around this raised boss in here, right?
Yes.
Okay. So the workflow is going to be, first step is to do a facing operation. So we'll pick facing. And then for the features to be faced, I'm going to click on Select Curve Edge Region, and I can select a surface edge from the model. You can see that I just picked this edge right here on the exterior most diameter. I accept the selections. I have a little selection menu that shows up right here. I can say click Accept it. So the edge that you selected is now highlighted in the part region. For the tool, I can select a type of tool. I could use like a face mill cutter, a large face mill, like a shell mill tool. You can set your feeds and speeds in here for it. And then you can go into the feeds and speeds. They're automatically loaded from the tool. You can set the clearance, the safety plane for all your non-cutting and transfer motions. You can set it to automatic. It'll automatically clear the maximum height of the part of the stock, whichever is higher. You can specify your parameters for roughing in here, your cut patterns. You can choose your cut direction, set your step overs in here. In the cut levels, I could specify the cut where you want it to begin the cuts from. You want to start from 0, and you only want to go down hundred thousands. So you can put that in here. You can also specify a lead in and lead out, how you want it to enter and leave the material. You can do the same thing. And generate will create your facing toolpath. So it's computing a facing toolpath. And the toolpath is previewed right on your graphic screen. And it's doing true arcs, so we're doing it in a circular pattern. It's an offset cut pattern. So now I'm going to go ahead and assign a color for the simulation in here. And then I'll go to the Simulate tab. We'll select the simulation window. So there's your stock and the work 0 set to the top of your workpiece. Now we'll select this operation, hit the play button, and you can see it shows your verification cut material simulation. You can always speed up the simulation as needed. You can also click on preferences if you wanted to increase the simulation speed to have it go faster. Do you have any questions so far?
No, I think not.
Okay. So there's the facing operation, the first step. In the next step, we would like to go ahead and machine between these two areas in here, right?
Yes.
So we could use the same operation. We could do a facing operation. I can right-click and do a copy and a paste. And now I'm going to go ahead and edit this operation. So in addition to selecting this drive boundary, I'm also going to hold my Shift key and select this edge in here. So I don't want my cutter to cut into this area. So I can pick these two. Now for the cut levels, I'm going to say I want to start over at this face, and then total depth I want to go from here down to this floor. So that's about a ½ inch in height, right? And the tool, what you have here, if you want to make changes or edits to it, you can do that. So there's your parameters. You can specify your stock to leave. You can also add a cleanup pass around the island. If you want to do a profile pass to finish it, you can leave some stock in here. Like I could say I want to leave 20,000 stock, and then you can use a profile operation to finish it. Now when I do a generate, it creates your facing toolpath right there.
Right.
So now I'll go to the simulation window. I'll change the color of the simulation so I can see the material being removed. I'm going to hit the play button. And there's your verification. We did it in 2 steps. We could do multiple steps, right?
Right.
So the material is cleared out right there. If you go back in here, you want to edit any of the parameters, you just double-click on it. In the cut levels, you can specify a depth per cut. I just put in 100 thousandths. If I want to change it or increase it, I can always modify it right here. Any questions so far?
No, I think that makes sense.
Okay. So saving your design part in Alibre automatically also saves all the machining operations, the CAM information to the same Alibre design part. So you're not creating any additional file formats in here. Now to program these holes in here, right, you have holes of different sizes in here, right? So this one is a 2-inch diameter hole, and then you have a hole that's a 1-inch diameter. So what size cutter would you like to use for programming these?
Well, we'd probably drill the 1-inch holes, and then, I don't know. Generally, I would drill a 1-inch hole in the big ones and then interpolate the rest of it with a, I don't know, maybe a 1-inch cutter.
Okay, so here's what I'm going to do. Use a hole machining, use drilling. And I'm going to use holes on a flat area. I just pick that face, and you'll notice that it automatically picks all the holes from that area. And I can apply a filter in here to specify, to exclude holes of a certain size. If you only want to go pick holes of 1 inch in diameter, you can say maximum diameter is 1, and you'll see that it automatically drops the other hole, or I can put in, like, for example, like 1.5. So it basically retains all of the holes, and then it drops the other ones out that are less than 1 inch, right? So you can go back in here. You can say apply a filter, or you could go back and just say you only want to select holes manually. You can just go ahead and pick each of these hole faces in here by just holding the Shift key. You can select the whole faces. Right?
Yeah.
So there's a couple of ways how you can pick the whole holes. Either use a flat area selection, which is faster, quick, and easy, or you can just say select these holes, and you can see now I have 10 holes selected in here, right?
Yes.
So I could be selecting the holes either from the top face or from the bottom face, depending on how you want the holes to be selected in here. We also have a toolbar called regions in here, where we can extract regions from a face. So I can say select a flat area. We can also apply filters in here, and I can choose select a flat area. I can just pick that face, and in this process, it will automatically create regions for each of these faces, as you notice it right here. You see that, sir?
Yes.
And you can also apply filters in here. So if you only wanted to pick holes of a certain size in here, I can specify to use a diameter. I could say go from 0.1 to up to 1.2 inches, and I can click create a new set, and then pick this face in here, and it'll automatically, you can pick anywhere on the face, and you will notice that once you select it, it creates holes for each of those regions. So there are several different ways how you can create it. So I have one set for the smaller holes. I can repeat the same set and go back and change it to specify the minimum is 1.2 and the maximum is, let's say, 2.5. And I can repeat the same step in here, and this will now create the holes for the larger holes, right?
Yes.
So that would be a very easy way to define, take advantage of predefined regions. Now we'll go ahead and program a toolpath. We'll say drilling, and we were going to select predefined. We pick the first set, so all the holes are automatically selected from the first set. You grab a tool for it, so we can add a 1-inch drill bit to our list in here. So you can easily add additional tools to your library, save up the tool, and now I can go ahead and set the feeds and speeds. Clearance can be set. In the cutting parameters, you can choose the type of drill, whether you want to do standard drill, deep drill is like your peck drilling, countersunk, brake chip. You have all the different cycles in here. You can also pick the depth from the part. You pick the top face, and then you pick how deep you want to go right here. And if you wanted to add the tool tip to go past it to make it a through hole, you can select add tool tip to drill depth. You can also sort them, go in a sequence, and then generate it. This basically creates a drilling operation for each of those holes.
Right.
Now, if you'd also wanted to include the other holes in here, the larger 2-inch holes, you can just go back and have all of them selected, the predefined regions, and then generate it. So all the holes are automatically added now. So that's how easy it is to edit the operation. And now you'll notice that it's drilling both
Yeah.
the 1-inch and the 2-inch holes.
All right.
And since we chose to add tooltip to drill depth, you will notice that the tool actually goes past to compensate for the tip of the tool.
Right.
In the next step, you would want to basically pocket or profile these holes, right? You want to interpolate it.
Yeah. Yes.
Okay. So we have a very nice technique to do that. We have 2 axes. We could do hole pocketing or we could do hole profiling. So hole profiling considers that the hole is already like pre-drilled or pre-finished, and then you can do a profile. It just as a helical cut. Hole pocket, it also clears the material out in the center. So we could start with the hole profiling in here. We can use the predefined region selection. You have your tool selected. We want to go with a 1-inch cutter. We'll define a 1-inch end mill. I'll save this up as a new tool, and it warns me that the same tool already exists, the tool number. So increment the tool number by 1. In the cutting parameters, you can specify the depth. I can just pick this face. Then I can just go pick the face at the bottom. I can, if you want to go past slightly, you can say you want to change, maybe make it 80 thousandths or 800 thousandths. You can add 50 thousandths to it. And then you can specify the parameters for your helical interpolation, your helix pitch. I can go like an 1/8 inch. Output through helixes. You can also control your entry and exit parameters in here. You can apply a sorting, very similar to how we did the drilling, and then generate. So that basically creates a helical interpolation for drilling it. And now I'm going to go ahead and apply, pick a color for the simulation. Let's go to the simulation window and select play. So there's your helical interpolation for the large holes. Do you have any questions so far?
No, it all makes sense. Can you define a clamp area for it to avoid if you're facing?
Yes, you can. What you would have to do is basically you create a sketch in Alibre. Let's do that here. So I'm going to go ahead and go to the view, go normal to the view, and I will define a sketch in here. So I'm going to create part modeling. Will activate a sketch, and I'm just going to go ahead and draw a rectangle that represents a clamp in this area right here, right?
Yes.
I'll define a clamp over here, and I'll do something similar over here as well. So I define a sketch. So now I have the sketch created. Let's display the sketch in here. You see the sketch? Now in the facing operation, I'm just going to make a copy of this so you can see the difference between the two. If you go to avoid regions, you can now click on select curves, and I can just pick that sketch right there. So that's the avoid areas, and then I pick generate. So you will now notice that the toolpath automatically excludes those areas.
Yeah.
That would be in the first facing operation I just did. So you can apply the same to the other operations too. So if you go back in here, run a verification, you'll notice that it avoids those areas.
Right.
So that's how easily you can define your avoid.
And this would all be included. This would all be included in all the versions. This kind of thing would all be included in all the versions. The main thing you get in the different versions is more access and more machining complexity.
Well, this is available starting with the standard configuration. The avoid regions are not available in versions that are below standard, which is Express. The standard includes, avoid regions. Now, with the standard, you have all of these methods: the hole pocketing, the hole profiling, all of these 2-axis methods. Now, the other versions have more. Yes, they have more multi-axis. The standard configuration allows you to program 2- and 3-axis, and you have a wide range of 2-axis and 3-axis methods available in here.
Right. Yeah. All right.
To answer your question about creating avoid regions for clamps?
Yes, it did.
Okay, great. So I'm going to go ahead and delete this operation. You can do a cut, or you can even suppress this operation out if you don't want the operation to be participated in your post-processing or in the machining workflow. Now, right-click and information will give you a machining time estimate of how long it's going to take to program these operations.
All right. Yeah.
Now, is this part going to be turned out on a lathe to cut this groove, or would you need to use like a
Well,
T-way cutter?
actually, it's a built-up part from 3 pieces welded together, so
Okay.
the groove would technically already be in there. But
Okay. Okay. Yeah, in case you had a need to machine that groove and you had like a face mill or a T-slot cutter, we have a T-slotting operation which you can use for programming it.
okay.
Okay. Now, any other questions on this part?
I don't think so. Do you have any?
Okay.
Yeah, that must be
So,
just. What's that?
So how do you get from here to the machine?
So that's with export G code then.
Right.
What about like the tool table?
You would right-click on the setup and then select Post, and this will generate the G code for the post processor that you select. So if you pick the ProtoTrack, it'll be
Right.
the G code that would be compatible for your ProtoTrack CNC machine from Southwestern
Right.
Industries. There's the posted code. Now I can also post this to the other machine which you have the achromatic controller. So there's your posted code. You can see the tool
Right.
numbers being called, and it automatically outputs the tool changes as well. So if you right-click and pick Post, you can change it to the other machine right here, which is the achromatic 2100, and I'm going to call this -2. So you can see there's the other program that's being output.
Right.
You can also
Okay, but then
generate
as far as the
information.
tool list, those numbers would need to match whatever's loaded in the machine. Is that?
You got it.
That would. Yeah.
If you have an automatic tool changer on the machine, you need to make sure that the tool that you define in your library matches the tool that's on your machine.
Right.
Now we can generate a setup sheet. You can right-click and choose Shop Documentation. This would allow you to select a template in here, and then you can specify a file name to it. By default, it'll pick the name of the part, and this creates a nice little HTML report which gives you information about the stock information, the material you're cutting, the total operations, the machining time, list of tools that you're using, it names the tool, and it also takes a screen capture. It gives you a detailed report. It shows each and every operation that's being programmed in here.
And that's included with all versions?
That's included in the standard and above.
Okay. All right.
Now, do you have a need to be able to program parts from multiple different orientations, like programming from the top and then from the bottom as well?
Yes, probably so.
Okay. With the standard, you will be able to program from one orientation. So in this particular case, we programmed the part from the top. So you would save this part out, and then if you want to program this part from the bottom, if you're using the standard configuration, then you would have to make a copy of this part. So I'm going to say Save As. I'll say part spacer, I could call it side 2. So I'm making a copy of this part in here, right?
Right.
So after I make a copy of the part, I would go back into the machine tool setup, and I would rotate the coordinate system. I can put in 180 degrees and want to flip it about the X. So you'll notice that now the Z-axis is inverted, which means it's
Right.
now normal to this bottom face, and I could define the stock material in here, go back and define the stock, and I would basically define the work 0, and then program these toolpaths in here. So I can apply a facing operation. So you can see that when I did a copy of the part, those operations were saved from the, you just made a copy of it. They were already existed in there.
Right.
And then I would basically program these toolpaths. So basically you're maintaining 2 separate files. Now in our Pro configuration, you can add multiple setups to program from multiple different orientations. Rather than having to create multiple files, you could actually create multiple setups. So you can add more than one setup. So that's one of the advantages in the Pro, which allows you to create multiple setups and program from multiple different orientations.
Okay, yeah.
So in this particular step, we just did a facing operation in here. Now to cut the step in here, does this hole already bored in the material that you're going to be cutting, or do you need to bore the hole in here?
The hole's already in it.
already in there. So you just need to do like a profile cut to clean up the step in here. So you could do a 2-axis profiling, and I could pick this edge right here, select that, and then grab a tool. We can use a 1-inch cutter that we defined, and then in the cutting parameters, you can specify the site to cut. We can say determine off the 3D model. I can just pick these 2 steps, and that's the total depth. If you want to break it up into multiple steps, you could do multiple passes, apply your entry and exit, generate. So that creates a profile cut to, clean up that step. And then I can go back and apply the drilling operation in here to select the holes on this face, and pick those holes, and apply a filter to exclude the other holes, and then generate the toolpath. So now we were able to quickly program the other side by reusing most of these operations from. Over here you can see that there's not much material being removed in here because there was no stock being left.
Right.
So there's the step being cleared. The stock shows that there's still a solid geometry, but since you already had a pre-cut hole in the blank, if you want to define a blank with a pre-cut hole, then you would need to have the professional configuration, which can do stock from selection. So you can actually design what the blank looks like, and you can define it as a blank. So the Pro has additional features, which allows you to have the ability to define stock from selection. So you can do stock from selection, also stock from extrusion as well.